In problem number 42, we're asked to find the derivative of the integral of an expression. Now we can use the second fundamental theorem of calculus to help us with this problem. One way to make sense of it is to think of this as two separate integrals. It's not necessary to do so, but it might be helpful. We're used to seeing these problems with one constant as a limit of integration and one variable as a limit of integration. So if we split this up as the integral from x to some constant c, and then another integral from a constant c to x squared, we can add those together and have the same value. So now, using the second fundamental theorem, we'll see that in this first term, we're going to get the sine of x squared. And since our constant is on top, the upper limit of integration, and the variable is on the bottom, we'll get the opposite answer of what we usually would expect to find, because we switched the limits of integration. Now, if we work on the second term, you see that we're going to get the sine of, I'm sorry, I wrote that wrong. That's not x squared. This is x cubed up on top, x cubed. So now when we put x cubed in for t and square it, you see we're going to have to now use the chain rule and multiply by the derivative of the inside, or the input, which is going to be 3x squared. And so now if we just rewrite this, we can see that we're going to get the opposite of sine of x squared plus 3x squared times the sine of x to the 6th power, using our algebra rules. And this matches option letter C. They just put the terms in a different order. Hopefully you found this video helpful. Thank you for watching.